I want to start talking about the graphs of log functions, and they're just the inverses of exponential functions. So we can graph them by turning and flipping. So I know that exponential functions come in two types. There's exponential growth, and I've got an example up here where the base is 2. And then there's exponential decay, and I've got an example up here where the base is 1/3. And remember, when I ask you to graph exponential functions, I'm usually going to ask you to include 3 points. We'll always have a y-intercept at 0, 1, and then 1 point on the right and 1 point on the left gives me the appropriate steepness for the graph. So if you plot the point whose x value is 1 and whose x value is -1, that gives you a point on either side of that intercept. So that's what I've done for both of these graphs. What I want you to do is pause the video, graph for me y equals the log base 2 of x. You're going to get that by just turning. Remember, we rotate 90 degrees to the right, and then we flip top to bottom. Turn and flip this graph. Keep track of what these 3 points become. Same thing here. Graph for me y equals the log base 1/3 of x. That's going to give us the two general shapes that we'll see for our log functions. We'll have one shape for log functions with a base bigger than 1 that are the inverse of exponential growth, and we'll have one shape that's the basic shape for log functions where the base is between 0 and 1. Those would be the inverse to an exponential decay function. So pause the video and graph me those two things. All right, I can't turn and flip my board, but I've done these problems often enough that I remember the general shape. I also know that when I take the inverse, I'm switching the role of x and y. So that's going to give me 3 points that are going to be on the graph of this log function. So the point 1, 2 is going to become the point 2, 1. The point 0, 1 becomes the point 1, 0. Notice my y-intercept there corresponds to the x-intercept here. And the point -1, 1/2 is going to become the point 1/2, -1. And you should have seen when you turned and flipped that you got a curve that looked something like so. That now is the log base 2 of x. You'll notice that let's actually write this out. The domain for our exponential function was everything from -infinity to infinity. The range for our log function is everything from -infinity to infinity. Okay. It gets less steep here, so it's going up a little bit more slowly, but this arrow has me going up and to the right. It's going to go infinitely far to the right and infinitely far up. So the domain of the exponential becomes the range of the log function. Okay. Now, the range of the exponential function was just positive numbers, because when we take a positive number to a power, we're going to get something positive. So the domain for my log function is everything from 0 to infinity. Log functions are only defined for positive arguments. Okay. So the domain, if I'm just plugging in x to a log function, the domain is just the set of positive numbers. You'll notice here the negative x-axis was a horizontal asymptote. When we switch the roles of x and y, the negative x-axis flips down to the negative y-axis, which is now a vertical asymptote. All right, if we look at this one, again, I'm going to just plot the 3 points first. -1, 3 is going to become 3, -1, or it's going to correspond to that. 0, 1 is going to become 1, 0. 1, 1/3 is going to become 1/3, 1. And so we get a shape that looks something like this. Okay. Now here, with the exponential function, my domain was everything from -infinity to infinity, And down here, that's my range. Everything from negative infinity to infinity. With the exponential function, the range was positive numbers from 0 to infinity. Now that's the domain for my log function. So, log function with any base, whether it's bigger than 1 or between 0 and 1, the domain is the set of positive numbers, the range is all real numbers. You'll notice here, when we had exponential decay, the positive x-axis was a horizontal asymptote, with the graph of the inverse of such functions, log functions with a base that's between 0 and 1, the positive y-axis is a vertical asymptote. Okay, so in general, if you're graphing a log function, it's going to have one of these two shapes. This is the shape that we'll see more commonly. The log function we work with the most often is actually the natural log, which would have a base of e. Okay, so we'll work with that in the next video. But you should be familiar with both of these shapes. Generally, when I ask you to graph a log function, I will ask you to include the points whose y values are 0, 1, and -1. Those are the points that correspond to the 3 points that I ask you to graph on an x value. But with log functions, it's actually easier, rather than giving you x values to plug in, to work with the y values. So you can expect the directions to say, graph this function including all the points whose y values are 1, 0, and -1.